Welcome to the deep dive. Today we are really taking a shortcut into algorithmic finance.
Yeah, we are.
Our mission: build a practical, auditable AI trading bot. And importantly, do it without needing, a PhD or a fancy Bloomberg terminal or a seat on the exchange floor.
Exactly. We're drawing directly from a guide that's all about building these modular, explainable AI systems, specifically for trading, looking ahead to, well, basically now 2025.
So for you listening, the idea here is to give you a clear plan, a roadmap really, and a working prototype you can learn from.
Right. We want to get past the buzzwords, understand what an AI trading bot actually is, maybe what it isn't, and crucially, how you can run this kind of project on your own laptop, keeping costs down.
Okay, let's dig in. When people hear AI trading bot, I think they often picture some kind of impenetrable black box, right? But the source material really hammers home that opacity is, well, it's the enemy.
It really is.
So how does this new generation bot differ from, say, the classic quant systems from years ago?
Well, fundamentally, it's still software turning information into action. That hasn't changed.
Okay.
But the big difference is cognition and communication. A traditional rules engine, it just executes.
Yeah.
If the 50-day moving average crosses the 200-day, buy. Simple trigger.
Right.
This AI bot, using large language models, it reads much wider context news, sentiment, maybe market regime shifts. And here's the key part. It explains its choice. It gives you a narrative.
I like the analogy they use. Think of the bot less like some autonomous genius trader and more like a junior analyst. This analyst can scan charts, yeah, but also parse news, summarize dense filings, and critically argue both sides, the bull case, the bear case, before you, the senior trader, actually sign off.
That's the agent mindset in action. But hang on, doesn't using an LLM like a junior associate introduce a lot of variability? Compared to just a fixed script, that seems like a potential issue.
That's the immediate question, yeah. LLMs are amazing with language, but their reasoning can sometimes wander. If we need decisions we can actually stand behind, defendable decisions, how does this modular structure help with that variability?
Okay, that's really the core idea here. Instead of one massive monolithic thing that's a nightmare to debug if it goes wrong,
Right.
the system's built from several narrow specialists, agents, basically. This structure forces you to see what's happening inside. It makes the whole thing way more auditable. If a trade recommendation looks off,
Yeah.
you don't hunt through 10,000 lines of code. You look at the specific report. Was it the analyst, the bearer arguing its case, the trader agent maybe? You can pinpoint the source of the mistake.
Okay, break down that virtual team for us. What are the specific roles the sources say you absolutely need to avoid just one agent making a bad call on its own?
You need 4 key roles interacting. First, you've got the analysts, maybe one for fundamentals, one watching sentiment, one doing technicals. They gather the raw signals.
Got it. Analysts?
Second, and this is crucial, the researcher pair, a bull and a bear. Their job is to actively debate the asset, pros and cons. It forces internal skepticism, which helps fight that LLM tendency towards overconfidence.
Okay, so analysts feed the researchers who debate. Then what?
Then the third role, the trader agent. It takes all that input, the analyst reports, the bull-bear arguments, and synthesizes it into a concrete proposal. An action, like buy or hold, and a conviction level.
And the last piece, the safety net.
That's the risk manager. Role number 4, and absolutely vital. Its only job is to hit the brakes, or even veto the trade completely.
Based on what?
Based on predefined portfolio rules like position sizing, maybe sector exposure, or if that bull-bear debate flagged a major risk that wasn't properly resolved, it builds accountability right into the AI's process.
That structure makes a lot of sense, and it leads us straight to the practical side. To actually build this, we need a starting point. The sources point strongly towards the trading agent's AI framework.
Yeah, Trading Agents AI. It's
Yeah.
recommended for good reasons. It's free, open source under Apache 2 license, and it explicitly models that small multi-agent firm structure we just talked about.
Okay.
Now, it's not like a plug-and-play system for your retirement fund day one. Think of it as a lab, a really good lab for teaching and experimenting with credible agent behavior.
So if someone listening goes and installs this, what are the big wins, the things that take them beyond just messing around?
Okay, 3 core wins. Number
Yes.
1, explainability, auditability, really. Every single step leaves a text trail. You see the analyst's findings, the bull's points, the bear's counterpoints, the risk manager's check, the whole reasoning chain.
Not just the final buy or sell.
Exactly. Number 2, flexibility. Because it's agent-based, you can swap things out easily. Different LLM sizes, different external tools for data gathering, whatever. And number 3, safety by design, specifically because you have that dedicated risk manager agent whose job is to catch, as the guide nicely puts it, silly overconfidence.
That focus on transparency and process feels right.
Okay, let's talk setup. Someone wants to get a demo running this afternoon. What do they absolutely need? The prerequisites.
It's kept pretty minimal, which is good for getting started. You need Python, version 3.10 or newer.
Okay.
For the brains, you need an OpenAI API key that runs the language models. And for market data, you need a FinHub API key.
FinHub. Is that expensive?
No, and that's key. Their free tier is perfectly fine to start. It gives you company profiles, end-of-day prices, the basics you need for initial experiments.
Right. And the setup process itself looks straightforward but crucial for managing costs later, maybe.
Yeah, standard good practice. Create a clean virtual environment for Python. Clone the GitHub repo, its Toric research trading agents. Then you set your API keys securely as environment variables. Don't hard code them.
Good point. And the first goal, just get something running.
Exactly. Proof of concept. Run a simple analysis. Pick one stock, say NVDA. Pick one past date, like May 10th, 2024. Run the script. The output should show you that whole multi-agent flow we discussed. Analyst reports, bull-bear debate.
Trader proposal, risk manager check,
Yeah.
everything.
Yeah.
If you see that, you know you've got an explainable bot working, not some mystery box.
Okay, here's the big question, though. Cost. People hear OpenAI API and worry about getting a massive bill, especially when learning and iterating. How do you keep costs under control early on?
That's a super important point. The biggest mistake is using the most powerful, most expensive models for everything right away. Don't do that.
So what's the strategy?
Model switching. The Trading Agents framework lets you specify different models for different tasks, like a deep flop model and a quick summary model. Switch both to efficient ones, something like GPT 4.1 mini or similar. Keeps the lights on and the bill tiny while you learn.
Makes sense. And limiting the actual work the bot does.
Absolutely. Limit the debate rounds between the bull and bear. 1 or 2 rounds often gives you the main signal. You don't need a 10-round philosophical debate for a first pass. Also, just analyze fewer tickers per run. And stick to end-of-day data initially. Don't jump into real-time, tick-level stuff until you really know what you're doing. That eats tokens fast.
You also mentioned data habits like caching. Why is caching static stuff like company profiles so important? It can't save that much money, can it?
It's less about the pennies saved on the API call, though that adds up. It's more about speed and reliability.
So.
If your bot has to refetch the company's sector or HQ address every single time it analyzes that stock, your whole analysis batch slows down. It adds network latency that makes your learning loop slower, and it's just bad practice if you ever think about moving towards faster decisions. Cache that static info once.
Okay, good practical advice. That discipline leads us to the next essential step, logging and evaluation. We keep talking about auditability, but before risking any real money, we need to know if the bot's decisions are any good, right?
Precisely. Forget connecting to a broker for now. First step.
Okay.
Log every single decision to a plain old CSV file. Simple text file.
Paper trading, essentially.
Exactly. Risk-free evaluation. The guide stresses building these kind of boring but healthy habits. Log the key fields every time. Timestamp, ticker symbol, the date you evaluated, the action it recommended, buy, sell, hold, the confidence level it assigned.
And the rationale.
The full text rationale. Why didn't it make that call? Get all that into your log file.
And once you have that logging set up, you can schedule it, right? Run it nightly on a watch list.
Yep, that turns your prototype into something you can actually evaluate over time. It becomes a system. The focus is on processes that are, maybe a bit boring, but that's a virtue here. Reliable and repeatable.
Okay, so we have a working prototype, logging its decisions. Now, the roadmap, turning this from maybe a clever toy into a genuinely disciplined tool. First step seems to be sharpening the data inputs. What does that mean in practice?
Right, this is where it gets more serious. Raw price data or just raw news headlines are actually pretty bad inputs for these reasoning models. You need to feed them structured features. Like things like normalized technical indicators, not just the price, but maybe the RSI value and whether that's overbought or oversold, volatility measures, sentiment scores derived from news but cleaned up and normalized, macro indicators maybe.
So why is giving it a summary like RSI is 72, overbought, better than just giving it the raw price chart or the full news article text?
Because LLMs are great at language and reasoning, but they can stumble or hallucinate when asked to do precise calculations or spot complex patterns in raw numerical data streams.
Okay.
By feeding it structured features, pre-calculated facts like RSI is 72 or VIX is high, You're giving the agent clean, deterministic inputs to reason about. You give the right summary, not the whole messy ocean of data.
The source insists this pre-processing needs to be deterministic, versioned, reproducible. Why is deterministic so critical there? Is it about controlling the model or just being able to track things?
It's really both. If your data pipeline isn't deterministic, meaning the same raw input doesn't always produce the exact same feature output, you get uncontrollable drift. You can't trace why the model's behavior changed.
Right.
Deterministic processing guarantees auditability. If the bot makes a weird trade, you can take the exact same raw data from that time, run it through the exact same version of your feature script, and get the exact same inputs the bot saw. If you can't reproduce the input, you can never reliably fix the reasoning.
Okay, that makes the data challenge clearer. Now let's talk reasoning and risk. We need that risk manager agent to be more than just, polite suggestions. How do we tighten up that risk layer?
You need a two-pronged approach. First, use the LLM itself for reflection, and second, implement hard-coded rules.
Reflection. How does an LLM reflect?
You basically task another LLM agent, or even the risk manager itself, to review the bull-bear debate and the trader's rationale. Ask it to look for weak spots. Did the argument consider liquidity risk? Is the confidence level justified by the evidence presented? It helps the AI critique its own thinking.
Okay, so that's the thinking clearly part. What about the hard rules?
That's the acting safely part. These are non-negotiable financial boundaries coded directly into the system. Things like never allocate more than X% of portfolio to one stock. Always have a stop-loss rule. Don't trade stocks with less than Y average daily volume. Liquidity filters.
Gotcha.
The source puts it nicely.
Yeah.
The bot has to be opinionated about survival. These rules enforce that opinion.
Opinionated about survival. I like that. This naturally leads to separating the decision from the action, deciding versus doing. Why is that separation so fundamental?
It's mainly about security and reducing what could go wrong, the attack surface.
Yeah.
Let the AI agents do the thinking, the analysis, write the rationale, propose the order. That's the decision.
Okay.
But the actual execution, the code that holds your broker API keys and places the trade that should be a separate, small, heavily audited service. Keep them apart.
So even if the LLM goes haywire somehow?
The execution module still has its own safety checks and won't just blindly follow a crazy order. And definitely start by connecting only to a broker's paper trading API. Zero real risk while you test that link.
Right. Paper trading first. Always. And finally, monitoring. You mentioned logging decisions, but this sounds broader.
Yeah. Log everything. Log the inputs the analysts use, log the reports, log the debate, log the final decision, log the outcome. But also track process metrics.
What kind of process metric?
Things like, how often did the trader agent disagree with the consensus from the bull-bear debate? How often did the risk manager actually step in and veto a trade? These tell you about the health of your decision-making process. Is one agent consistently off? Is the system getting too aggressive, too timid? Monitoring this stuff turns the bot from just a script into a system you can actually manage and improve, an asset.
Okay, so we've built this transparent, hopefully defendable system. Time for the reality check. We're relying on LLMs for reasoning. Where do they typically fall short in this kind of high-stakes financial context?
Well, like we touched on, they write beautifully. Great prose, convincing rationales. But they can be confidently wrong.
How so?
They might prioritize sounding fluent over being factually precise, especially when summarizing complex or contradictory financial data. This is why you always need structured data checks in your actual code. Let the language model explain and argue, but rely on code for the hard facts and calculations. Don't let it make up numbers.
So the ultimate goal isn't necessarily guaranteed profits from day one, is it? It's more about having a process you can actually defend.
That's exactly it. The benchmark is, if you, the human overseeing this, can't explain a decision the bot made in 2 clear paragraphs to someone skeptical, the bot needs more work.
Makes sense.
The upside, though, is potentially huge. A system like this can adapt much faster to changing market conditions than purely rule-based systems. And critically, it can be taught to recognize uncertainty, to say, you know what, the signal isn't clear here, and just skip the trade. That kind of humility is incredibly valuable long-term.
That really sums it up. The real win isn't some lucky trade. It's building a system that effectively thinks in public. You can see the whole chain: analyst signals, the bull bear sharpening the arguments, the trader making a call, and the risk manager providing that final prudent check.
So your actionable next step, pretty clear. Call that Toric Research Trading Agents repo. Run the command line tool with a test stock, and then really spend an hour just reading the logs it produces. Go through a full decision cycle. The goal is an explainable bot you understand inside and out.
Which brings us to our final thought for you to ponder. We've established the system needs to admit uncertainty, to show humility, and skip trades sometimes for safety. So thinking practically, if you're coding this, how do you actually measure and teach that concept of humility to the model? What would that look like in its final output, its decision rationale? Is it a separate score, a specific phrase like signal unclear deferring action? How do you quantify and encourage cautiousness in an AI? Something to think about.
Until next time.